Hello. Today, I will talk about the design of the antenna by Yaki Yuta. This is my antenna. Before we change the antenna today, we changed the connector from the original SMA connector with 75 ohms resistance. Then we made a printed board with copper on both sides and cut it to the size we want. The width is 5 centimeters and the length is 31 centimeters. Then we cut the copper that we cut in half to connect the connector head that we use to measure the reflection coefficient from the load to the SMA connector with 50 ohms resistance. So we have to change the connector from the Yaki Yuta antenna from a 75 ohm connector to a 50 ohm connector. After that, let's connect the antenna to the VNA and measure the coefficient of reflection from the load. The reflection value from the load should be very negative, meaning minus 15, less than minus 30. Because our antenna is very negative, it means that our antenna does not reflect back to the load at all. The signal that is released will not return to the transmitter. From the actual construction, the size of the constructed dipole antenna is 5 centimeters wide and 31 centimeters long, with a distance from the antenna to the reflector of 8 centimeters. After the construction of the dipole antenna is complete, measure the coefficient at the 440 MHz point. As shown in the figure, the measured value is minus 26.34 dB. The radiation pattern is obtained by taking measurements from a wave generator connected to a transmitting antenna, in this case a dipole antenna, and setting the frequency and amplitude. The reference value of my reference dipole at 440 MHz is minus 58.93 dBm. Connected to the transmitting antenna to wait for the transmission. The next part is our receiving antenna, which was originally a Yaki Yuta antenna and was modified to be a dipole to connect to a type of communication module, and set up the machine by adjusting the frequency range that we want, a total of 3 values, start, middle, and end. After setting the frequency range that we want, set the marker to see the signal in the range that we want, and turn on the RF generator to release the signal by pressing the RF on/off button on the machine. After releasing, note down the antenna value that has been set to the 0-degree position and slowly move the receiving antenna 15 degrees at a time until reaching 360 degrees. Then read the value from the machine and write it down on paper. To plot a graph in Excel or a program that can plot a graph, the radiation rate graph of the waves I got is as shown in the picture above. In actual practice, the measurement was done in the first area, which was the 18-story rooftop building at the Suvarnabhumi University of Technology, Nonthaburi Center, Southern Campus. Data could be sent and received to the guardhouse, a distance of approximately 153.74 meters. After moving the area in front of the court, the two brothers in transmitting and receiving data, the antennas on both sides could not transmit and receive data, so it was known that distance and obstacles had an effect on the transmission of waves. Thank you for today. See you again soon.